So welcoming you today to this joint effort of Invest Hong Kong, TÜV Rheinland, and the German Chamber of Commerce. The reason why we decided really also as the German Chamber to support this project in meaningful discussion is quite obvious. We as the German business community started already last year with a huge sustainability series, Green Solutions from Germany, because sustainability and protection of our nature is the core of whatever we are doing. Secondly, what we can see later on, the textile microplastic challenge has a lot to do with sourcing and trading, as we'll learn.
While we are here today in 2021, talking about how textile industry and textile products contributes to the microplastic issue, information about this was already out in 2011. You see here Professor Mark Brown, he's based in Australia. He already had the report. It was only in 2014 that it was widely reported and brands started to engage even further. Additionally, let's imagine now how information about microplastic shedding at finished product level, at fabric level, at garment level can be correlated with microplastic shedding at pre-consumer stage, at production process, depending on the wet processes, depending on the fiber construction, depending on the fiber composition, how all of that data could perhaps tell a story to designers, to manufacturers, that they be able to configure their production processes, their fiber composition in order to eliminate microplastic shedding. So the idea is to combine consumer stage data with pre-consumer stage data.
Rakash for the kind introductions, and I'm Cindy. So we have Frank here.
Hello.
So we are going to talk about our ideas of our project, which is to develop the real-time detection of microplastics in the oceans. Smaller ocean plastic, like microplastics, so they also pose different threats to marine ecosystem, such as the zooplankton will accidentally ingest it into their bodies, and then they will accumulate and magnify its toxicity, which is attached on its surface and then along through the food chain. All right. So, and then we understand microplastics is everywhere, which means that no matter in the food, even in the salt, and in various coastal environments, even in our drinking water, and even in the air as well. So they are everywhere. So what can we do to deal with the problem?
Fish actually is the one with the autonomous function. So we aim actually to develop the device that can do the real-time sampling and also the detection of the microplastic, or even we say is microfiber. Okay, could be in the coastal area that we want to know about what types of the microplastics and also how much actually of the microplastics actually in the sea. So that's why what we want to do is to use the kind of like engineering tools. Say we can have like to quantify them, to characterize them, apart from the lab one, because the lab when we do is a kind of like using the very sophisticated equipment like FTIR or even the Raman, but we just make it a very simple detection method. Yep. So I think this is our future direction, not just only the testing actually in the kind of like in the ocean, but also we can talk about like a different kind of like a water sample, say in the textile industry. So we have lots of the like a wastewater, actually they may contain those of the kind of like a microplastic or even the microfibers. Like me, actually, I'm working on those of the research in the washing machine, those of the effluents actually from the washing machine. We may know that how much of the microfiber or even the microplastics there. Using these kind of the technology, then we can apply that and also implement in the commercial side.
Economic Outlook reported that the textile industry consumes an estimate of 74 million tons of synthetic polymer, such as polyester, acrylic, nylon, and polypropylene, and an addition of 7 million tons of synthetic nonwoven. Element Then McKinsey reported around 0.5 million tons of microplastic were released from the textile industry. Our research team takes microplastic as one of the key topics under research theme sustainability. We look closely with industry, apply advanced technology to ease a global pollution concern by tackling one of the main pollution source of microplastic pollution, then put the global ecosystem in danger. First, we would identify the source of microplastic in textile production stages. So far, most studies on microplastic and the textiles are focused on garment and the garment laundry. Yet, little has concerned on the origin, the fiber, yarn, fabric, and the garment manufacture process. We know in the production process, raw material handling, fiber and the yarn spinning, fabrication such as knitting and woven, wet process such as dyeing and finishing, and the garment making could release the microplastic due to the mechanical force and the chemical stress. But so far, little comprehensive study has been done. In 2021, we kicked off another project aimed to develop a complete solution, not only separate microplastic from wastewater, but also aggregate the filtered microplastic from cluster in a microscope scale to provide convenience to further handle them. In our project, we focus on developing a microplastic filter machine that is targeted to continuously collect the microplastic from wastewater. The machine is also expected to aggregate the microplastic to form a bigger piece, the micro scale, for convenience to further treatment. We apply the technology called acoustic manipulation technique. So this technique actually is now well developed, applied in the biological and the life science. Acoustic manipulation technology is found to be very effective compared with other existing technology. We expect that the system can further contribute to serving as a base for further application study in developing similar tech machine for handling the microplastic from other industry and even in the marine system. Our preliminary results so far is very optimistic. Okay. Very low energy consumption and very effective. We are now exploring the scale up by the system design. So as a responsible consumer, manufacturer, brand, and the industry, the topic of microplastic and the textile needed to be taken care of in every step of garment production and the use. From our INS side, a deep understanding of the microplastic source, behavior, management tool, and the separation and the collection method would help us contribute to control the microplastic release, reduce the impact to the environment.
These topics, which are extremely topical and extremely relevant. I'm a firm believer in things being demand-driven. And I think as we start to educate the consumer about some of these issues, consumers will be crying out for better and higher standards for companies to live up to. And I think this is part of that whole process of, you talked about the Gen Z and the millennium generation. They are more aware perhaps and maybe a bit more vocal militant. And I think that's a really good force to wake us up. We are